Good. So, good morning, and thank you very much for joining this talk, and thank you very much for Luc and the whole team for organizing this room. I'm going to talk about continuous integration for open hardware projects, where I have to say we are not really the experts. I'm like a little bit trying to describe where we are now, and I'm happy to get also information from you guys and any questions that we could work on together. So, my name is Mario. I'm from Germany, but I stayed 10 years in Asia, and we had a lot of projects in Asia, but we felt a little bit cut off from the community, right? I mean, like FOSDEM is here and everyone just coming, but like in Asia, like at that time, 10 years ago, we felt a bit that things are going on everywhere else, and we don't meet the people that we usually meet in Europe. So what we thought is like, we like FOSS-free and open source software and like hardware as well, right? And we need an event. So we started FOSS Asia 10 years ago. And at events, people meet and have ideas. And then we say, oh, yeah, let's open a Git repository. And 10 years later, suddenly you produce hardware. So that's the story in short. And then, of course, like I'm from Europe, so I also started a company here in Berlin. It's called Open Tech. And we are running projects together also with European partners. For example, like within the Horizon 2020 program. So we're always happy to make open hardware sustainable also economically. And I like languages. That's why I like to go to different conferences, and I like international music. So it's like really cool opportunity. So I want to tell you first a bit like what we are doing, what projects we are doing in regards to hardware. So we have the Pocket Science Lab project that started 2014, and it's a project that that I can give it around actually. So it's a project for measurement tools. So the idea is to have many measurement tools in one, and there's also an app on the App Store which you can check out. We have many integrated components. We have a desktop app. So that's pretty cool, and it sells well in Japan already. So how it works here, you connect basically a device to the mobile phone, for example, Android. Unfortunately, iOS is not supported. I think many people know the problems with Apple. It's not so easy actually always to connect something to Apple. And then what you can do is, for example, you have these different tabs, and behind each tab there is an instrument, for example, an oscilloscope. So something cool that happened recently, people said actually we can also use that for robotics. So we had this idea that there are robotic arms. They can go into different angles, and you can drag and drop, for example, an angle into a timeline here. So getting into robotics as well. And here are a few instruments that are on the device. So apart from oscilloscope, we have a multimeter, logic analyzer, wave generator, power source, accelerometer, and more. And I don't know if I said it at the beginning. Of course, it's all open hardware, right? I mean, we don't control the chip, but like I think like in this track, it's clear that we are talking about open hardware. Another thing that we are doing is this this badge. So this badge is not open yet, but we are working on it. The first step was that like there was this guy on the internet. He basically reverse engineered the protocol. And based on his hack, we were able to do an open source app already. Looks like this. It's also like just like type into your phone. So that's the first step, and we're really getting excited to do more here as well. So you can save and export clips. You can draw on the badges, something that we do. And the third project that we're doing currently is the Neural Lab. There are already other projects like OpenBCI. Don't know, is anyone here from OpenBCI? No. And there's also a project that is called Braindrino. Basically, the idea is that you can collect your brain waves, and then you can analyze them. For example, it's relatively clear already if you want to, for example, know focus or relaxation, things like that is already possible. And then it's the same model as with the Pocket Science Lab. We make an app, and you can basically do it. So so what we are doing is we are already producing hardware. The Pocket Science Lab is on sales, and I'm sharing a bit how we are trying to get better in development. And so our idea was to use continuous integration. Many know it from software. It's like out there since the 90s. And continuous integration has been developed with the objective to reduce integration time and to continue to provide continuous software updates. Yeah, so builds. Okay, and yeah, continuous integration of software today. So you could build and test after each integration in a continuous cycle of builds. So for example, you make a pull request and then you can basically test, does your pull request work? This is in software. So the goal is that integration becomes kind of a non-event. It's just like going on, and it's always clear that yeah, that pull request or that merge request, that will work. Yeah, and cycles are developing, building, compilation, executing automated test and inspections. And continuous integration, you can also say continuous deployment could be part of that. So you deploy the software automatically, right? For example, on a server, like yeah, Google and so on have made it very easy to do that with the cloud. But we don't always want to be on the Google Cloud with our software. So it's also possible to do that with scripts. There are other solutions to do this as well, like so continuous integration, continuous deployment. So usual development workflow in FOSDEM. So in FOSDEM project. So we have around 200 repositories and like more than 4,000 people registered on our GitHub, right? But we all know big names. People come and go and then don't unregister, they just stay. And of course, we're happy to keep everyone connected. So whenever somebody tells you big numbers, take it with a, how do you say in English, grain of salt, right? So, but like we have a merge pull request on average every 15 minutes. And so that's kind of a good thing already. And this is our workflow. So at first, function or feature or bug is solved or developed in the developer workspace. So how we are working, we don't have feature branches. Like what we had in the past, we also tried that out with feature branches and so on. And then like some developer like gets a job or has something else to do and disappears. And we have like 40 feature branches. And we're losing track, and then somebody says, "Oh yeah, I'm working on this feature." No, somebody else works on this feature, but like it's not taken care for months, and you know. So we said, like, look, it's great if people contribute, but like it's a lot of overhead to take care of like what is actually going on in all these different projects. So what we say is, people work in their own workspace. They make their own branch in their own repository, and when they are ready, they can then make the pull request from their own forked repository. Yeah, so not inside the project. So and yeah, how it's then done. Of course, the developer runs the build locally and solves any integration issues. The pull request is finally made, and then we have usually like, I don't know if there's any repository where we don't have a CI tool. So let's say Travis CI or Circle CI. We like GitHub Actions, of course, it's a cool idea, but we are not sure yet how much integration that would be. Like if somebody moves a repository and they don't use GitHub, does it still work with GitHub Action and so on? So we are not clear. We don't want to have this kind of vendor lock-in. Yeah. So at the moment we're still like focusing on those. And yeah, so tests are run. Of course, developers need to write tests, and yeah, if everything is good, the code is merged, and as I said, in some cases, automatically deployed. So how can we transfer this idea to hardware development? So what's the difficult or the difference or the similarities of this hardware? So we have configuration in hardware projects, of course. Okay, that's what we have. Can write that into code. Writing and maintaining test cases, test scripts is also possible, right? I mean, hardware is not just like hardware. There's a firmware on it. There are some test cases that we could run, for example, on that as well. So all this is possible. Yeah, so you could trigger various test scenarios. You could also collect metrics. Yeah, you could analyze results, keep track of build logs. Something like that. And yeah, we had a talk yesterday of KiCad in another track. So it's also cool and what is upcoming in this area. Yeah, and so want to go a little bit like how we are doing this now with hardware. How does it work with hardware? So we are producing in China. I think like production in Europe is also getting better and better. but actually we had a lot of people who speak Chinese. So for us, it wasn't like a big gap that we need to go to a provider and check this out. For example, this is WeTED. The FOSS Asia office, main office is in Singapore. So that's that international hub where people speak all kinds of different languages. And he is a Chinese speaker. So he helps us to get the hardware development done in China. And it's really important because if I ask something in English, they say yes. And if you ask in Chinese exactly the same question, they say, oh, maybe not. Yeah. So so it's really good that we have that. And there are a lot of questions, I think, that we cannot go into detail now in here in these sessions, but I would like to also I think other people are also thinking about this integration things, and there are a lot of questions coming up. For example, we have all these machines, and like this is not like Travis CI, and then like Travis CI sends the data to this machine, right? For example, so this is something that I think is important to talk about, and of course we want. That needs standards, that needs integration, that needs APIs. And it's very important that we talk about these topics here in the open source community, because we don't want companies coming up and having the same fights that we had with free and open source in the past, yeah, where people say patents, non-standard software, and so on. So this is all important, and we have some experience here producing this already, so we're happy to work on you guys. So okay. And so integration from hardware now, our wish list. So configuration and testing should be, getting easier. Yeah. And so when we, for example, we would like to learn more what CLI tools are out there, what are other people using, what are the things missing. For example, there's this company that we are talking to, Wikifactory. Yeah, they have ideas. So and we have this consortium on a European level where we actually collecting these questions is already a big thing. Yeah, so if you could talk to me about this, for example, the automatic creations of BOM, bill of materials. Yeah, where you have like a list of materials, and for example, you have different suppliers, yeah, Farnell or others, and you can upload your bill of materials and automatically see what is the outcome, what is the cost, what's the cost if I order 100, and so on. So all these things, right? Well, because what we want with continuous integration, we want the same thing as software, yeah? Make a button, make a pull request, merge that, build the whole thing, make all the tests, but actually build the real device, yeah? So it can be shipped and merged. That would be our dream. So what do we need to make this happening? Of course, we want to learn how far can we go in a digital way. Yeah, I mean, what can we solve digitally, and what can we do in regards to producing real prototype devices? You know, JLC, PCB, and so on is just so cheap, like $5 or something, and you have a board already. So that's cool. So, and possibly automatic recommendations. Why not write YAML files and say, okay, this producer, for example, or this component supplier is supporting the FOSS community, and why not write that in the YAML file and make that a preferred producer of open hardware or something like that? I mean, all kinds of things that I could imagine to really grow the ecosystem in open source hardware. So what we see is basically in the hardware creation process, it's a similar cycle to software. Yeah, I mean, especially the further people are away from the development, I think the more they think the process is really different. But we feel what we learned so far about creating and producing hardware is it's really similar. So you, for example, so you have this cycle, right? You have this cycle, and you orchestrate task in a sequence where you then have a pipeline. You test it, you improve it, and you receive feedback and continue development on this feedback. I mean, it's really similar to software development. And so to make hardware CI possible, we an automation engine is really necessary, yeah, and should be able to deploy. I don't know. We don't have so much experience with FPGA, but I think there's this project of Bunny Huang and Sean in Singapore, and we connect with them a lot in Singapore, right? They're based in Singapore. We have the FOSS Asia Summit in Singapore every year, so that's really cool. They had this small FPGA USB development device. So that's cool, but not everything is FPGA, yeah, and not everyone knows about it, and I don't know their pros and cons. So maybe we could have people who really know about this, because I see some people are nodding. Yeah, maybe we can have workshops on this in future, learn more how to do that and develop here apart from the prototypes. So how far are we now in this endeavor? So what we are doing, for example, we are creating automatic deployments using kit space and YAML. I haven't seen Caspar here at the event like he was here last year. So for example, we integrated a YAML file. So kit space is pretty cool. It already does a lot of things what we need. So it enables an automatic generation of kind of like a list of things to build. Maybe I just show it. It's easier to show than to talk about it maybe. And yeah, so on each merged pull request, this YAML file is executed, and it connects to kit space, and it generates a part list. And then this part list can be matched with different suppliers. So this is basically still on the level of part lists, but like, why not bring this to the next level? Like, let's say to really produce the board and to see what else we can do. So we have this repository here, for example, of the Pocket Science Lab hardware. And it's a very simple YAML file. So it basically tells you where is the Gerber file, where are the Gerber files, and it has a link to bomb sheet ODS, which was before automatically created by KiCad. Yeah. So we are already going into this direction, and and then like this YAML file is executed, and then we have this page on the KitSpace website, and KitSpace itself is open source, right? I mean, like, that's really important for us, yeah? We can always, like, there can be cool services that are not always open, and we use them, like, you know, GitHub itself, but like Git is open, and here even like the whole KitSpace service is open. So they generate automatically these links also, and you basically can click, then you can, for example, click adjust quantity. So how many like prototypes you want to produce, and then you can see what is the price, are these components available, and you can click on any of these suppliers and check out and then basically order it. Yeah, and I mean, it sounds really great already, but yeah, the question is how standardized are these components lists always? So you still should check. You shouldn't just like go there, oh yeah, Mario said that and let me try that out. You should still check, are these the real components? Like sometimes like there might be slight differences or yeah, like, so that's something we need to work on and get more experience. So from continuous integration to sustainable continuous deployment, redeployment, and recyclement. Yeah, 10 years ago we had this talk. Eben Molen came to Berlin. The Chaos Communication Congress was still in Berlin, and he said open hardware is the next big thing. And then there were people talking, yeah, it's really good for the environment. It's all these, it's sustainable. Like it's not like it's right to repair and all these things. Yeah, and now 10 years later we have this topic, and I'm like, sounds like a déjà vu. Yeah, and but like it's also an opportunity for us. So we shouldn't be tired to just repeat the conversations that we had years ago. We should really try to do this. And this whole thing about open hardware and continuous integration could be deployment. Let's really like think into the future. It's not just like about building hardware. Could we also do something like de-assemblement machines? Yeah, where we say here are components. Just like you can deploy your software again on a server, could you like deassemble the hardware and do this, right? I mean, like it's not impossible, yeah. And so this is the thing. If you really think like everything is open and you have the CI, you could also have the how to call it, yeah. Let's phrase a sentence and let's make it big or something. Yeah, I mean, so that you deassemble. So CI solutions enable us to publish a new version and devices to be produced anywhere automatically. Here, another thing, right? We can ship the final design everywhere in the world and produce it locally. I mean, we're always talking about small boards, but how about we talk about cars and trains and spaceships in the future. Yeah, we could do all kinds of things that should all just be open. It is just like necessary for sustainability. And so we need machine integration to deploy fully automatically. So it's a problem, right? I mean, these machines that we see before, I showed you the picture of the what's it called in English? I don't know. So where you put the reels in and you produce the hardware and so on, right? I mean, they are not open. Yeah. I mean, I was in Shenzhen, not last week, so relax. So a while ago. So last year. Yeah. So right, and they have these machines, and they tell you, wow, $20,000, and you can produce everything. So I don't know, but like, right, do they follow open standards? Like, what can we do here in this area that we can really plug in? We send our hardware design here, and they really do it. And how open can we get that? Let's work together on doing this, and this is something that we try to also push on the European level to have more research, right? I mean, when they have these big research projects, and yeah, I don't know, $5 billion, right? I mean, like, and there's just the word open hardware somewhere in this big European book that they do, right? And okay. Yeah, all these car manufacturers, big companies and so on, they get like maybe like most of it, but how about 200 million really for creators of open hardware companies that do that and so on? So that would be good. So let's get these topics also on a European level and connect on this. So this is important. Yeah, I already said we need disassembly machines. All devices could possibly be automatically be disassembled, and components could be reduced or recycled. We really need to go in this direction. So continuous integration can enable us to make open hardware economically sustainable. I mean, I always see this sustainable topic in regards to the ecology, but we also need it in economically. And this is something that I'm trying to do. So because I know a lot of hackers, and they make, yeah, they do something, and for example, we had this cool project where we hacked the knitting machine and IAP, and we collaborate and so on, right? But then the project is done, and they're happy, we achieved the goal, so let's move on to another project. So it's not really about like changing the fashion industry, make it into a circular economy or something like that. And that's something that I would like to do. Really like work with people together on the missing parts and pieces to make this possible. And it all needs to be open, because if I don't have time, somebody else should be able to continue the work that we are doing. So, and of course, like this whole process makes development more reliable and faster by automating parts. So, right, I mean, we have all these problems with the environment and so on, but like maybe could we also solve these problems faster? I mean, it takes 7 years to get like from design to really like creating a car. Could we shorten this process by automating these integration processes even on a really big level? And could we lower costs? Yeah, I mean, that's all like kind of, I think, like people nodding here. Of course, we can lower cost by doing this automatically. And we can speed up regular updates and support the building of a developer and user community, which cannot be copied. Yeah, I mean, people always say, like, we had this talk this morning of the of Chris and so on. It can't be copied, and we need the community, right? I mean, you can always copy hardware, you can copy software, but you cannot copy a community that's dedicated. So this is impossible. So where to get the hardware? By the way, that I showed at the beginning, you can just go to FOSDEM. You can, of course, download all of it. Some people say, oh, it's not really open, the chip is not open. Yeah, unfortunately, we are not that far, but I know many people here working on this. And you can order it everywhere. And of course, you can collaborate with us. You can, if you have a company or something, you can talk to us if there are any ways to share experience, and maybe do workshops, meet us on the project chats. We have a few hundred people there, so it's really cool to connect. And here are the chances to connect, for example. So the FOSS Asia Summit is in Singapore from March 19 to 21. We also have like a KiCad Dev Room on Sunday when we have the Dev Sprints. So that's cool if you're able to come. And the Open Tech Summit Community Day in Berlin is on May 21. So would love to see you guys there. Thank you very much for joining. So how's the time? I think there's no time for questions. Is there time? Oh, no. Yeah, okay. Good. So just come to me. By the way, there's a FOSS Asia stand on the second floor or first floor. Depends on from which country you come and how you calculate, right? So it's not on the ground floor. It's one floor up. Yes, right. Thank you very much. Okay, so because I forgot to ask.